Hello and welcome to my talk, Collecting App Container Metrics with Sidecar Buildpacks. In the next minutes, I will talk about my experience I made when I tried to solve the issue on how to get system metrics within an application container. My name is Hartz and I'm a sales and platform engineer at anynines. I'm in the world of Cloud Foundry since more than 5 years now, and I joined my first summit also in 2016. A huge part of my job is working together with our customers when they integrate our solution for on-demand data service into their environment. Monitoring of applications and containers is an important topic across all our customers. Whereas the application metrics can be provided by the application itself, it is hard to get system metrics out of a container. But do we need them? Some words about observability. When I started with professional software development more than 20 years ago, application performance monitoring, short APM, was effective enough to monitor monolithic applications. Nowadays, more and more developers are adapting modern development practices, and therefore it comes to shorter release cycles. So the needs for monitoring have changed. Observability seems to be the enhancement of APM. In general, observability is the extent on how you can understand the internal state of your application system where the container, where the application runs, is a part of. To investigate why an application stops working, it is essential to have a good understanding in which condition your application runs. This includes disk, memory, and CPU usage. The application developer perspective. In Cloud Foundry, applications are running in garden containers. These garden containers are distributed over several Diego cells. A Metro agent, which is running in a Diego cell, is not only collecting the logs, it also collects the metrics from each container and sends them to the log aggregator. This is just a simplified representation on how this is working inside Cloud Foundry. An application developer doesn't have access to this data which is processed by the log aggregator. He only owns his own application. For sure, with the command cfapp, you can collect some basic system metrics, but you can't use them to set up alerts. Or do you really want to sit in front of your computer and observe the metrics manually? Okay, how we can get the system metrics now? I think one thing is clear now. The only place where we can collect these metrics is inside the application container itself. But when you SSH into such an application container, then you will recognize that with the htop command, for example, or any other Linux tool, you can only get the host matrix and not the container matrix. The next issue is where to collect the matrix. Integrating into the application itself can be hard. Depending on the programming language and the framework you are using, you do not have access to the system resources itself. The most important point is that the application is the wrong place to collect the metrics. Based on the single responsibility practice, it is not a responsibility of the application to collect the system metrics. So let's define a solution blueprint which is rather simple. We only need a piece of software which can collect the system metrics, a metrics collector. And then we need a way to ship this collector into the application container. Let's talk about the metrics collector. After some research, I found several possible solutions. I'm pretty sure there are a lot more. And the different solutions, I found the one which I think is the most promising one. I'm developing software since I was 12. It's more than 30 years ago. And I'm always asking myself, is there an easy way to develop things by myself? So a small Go application could be a good choice. But when you start investigating how to solve an issue, you will always find other solutions which are worth to have a look. A Golang app would have a small footprint and you can quite easily access system resources. Linux containers rely on control groups, which exposes metrics like memory, CPU, and others. Control groups are exposed through a pseudo file system, and you can find the file system under sys fs cgroup. Under that directory, you see multiple subdirectories, which actually correspond to a different cgroup hierarchy. There's also a good library you can use to get the system matrix. Also an alternative is the Prometheus node exporter. It is a pluggable OS matrix exporter written in Go. I understood it that way that the node exporter serves an endpoint which can then be scraped by, for example, Prometheus. The node exporter is actually in version 1.1.2 and maintained by Prometheus. It is under Apache license version 2, which means you can use it quite easily in your projects. A more powerful agent is Telegraf by Influx Data. This tool was pointed out to me by Lukas Frenzel and Jürgen Freund. A bit later, I will talk about a project they are working on. Telegraf provides a really powerful plugin system, as well as for import and export plugins. You can almost collect each kind of information from various sources. The list of the importers is long, and it starts with ActiveMQ and ends with Zookeeper. Also, there are a lot of exporters you can use to send the matrix to each kind of endpoint. Telegraf can do a lot more than just sending the matrix to a Graph exporter, like I want to do to solve my issue. I'm really impressed by the possibilities provided by Telegraf, so that I just had a rough look on other solutions. Like I said, there are a lot more solutions you can use to solve the same issue. The last question I will discuss is the way on how to ship the matrix collector into the application container. The talk is called Collecting App Container Matrix with Sidecar Buildpack, so that it is not a surprise that I will use the sidecar pattern to ship the matrix collector into the application container. I think the pattern itself doesn't need that many words. A sidecar is attached to an application and extends its functionality. Important is that it is just loosely coupled. Sidecars are supported by Cloud Foundry since 2019. They came with version 3 of the Cloud Foundry API. There is a blog post I can recommend. It was published in 2019 when sidecars in Cloud Foundry were officially announced. It described what sidecars in Cloud Foundries are and how you can use this mechanism to enhance your application. Adding a sidecar is really simple. You just have to adapt the application manifest by adding a sidecar section. There you described which process you have to start. A downside of this approach is that you have to ship the sidecar within your application package. More powerful is to create a Sidecar Buildpack. You could make the Buildpack available to all users in your system. Using the sidecar would only need a change in the application manifest, and there's no need anymore to ship the sidecar within your application package. Building a sidecar build pack is not that hard. The simplest form of a sidecar build pack contains at least the supply script in the bin folder. This script installs all needed components parallel to the main process within the application container during the supply phase. The script can also create a launch.yaml file. This file would be responsible that the sidecar process could start automatically depending on some small conditions. If you do this, if you create the launch.yaml file, then the section in the application manifest where you define the sidecar would be obsolete. You just have to mention which sidecar build pack you would use. The manifest.yaml is just a description of the sidecar build pack itself. Telegraf sidecar build pack is a pretty good example how the solution in the end could look like. This is the project I mentioned before, which is developed by Lukas Frenzel and Jürgen Freund. I do not want to invent the wheel a second time, and they put all the ideas together in this sidecar build pack. When you add the Telegraf sidecar build pack to your application, it integrates Telegraf into your application container and applies also a default configuration to it. All system metrics are then streamed to a Graphite endpoint, which can be then scraped by Prometheus. I highly recommend to have a look into this repository. And this is the solution I will go with. I think that is all you need to know when it comes to answer the question how to collect app container metrics with Sidecar Buildpacks. When you know what to do, it is not a rocket science anymore to get all the information you need. For further questions, feel free to ask me in the Q&A session after this presentation, or meet me at the Anynines booth within this virtual CF Summit. Once again, thank you for joining, and don't forget to follow Anynines in our social media channels.
So to the question, so when you add the build pack to your app, I assume it will open a port that would have to be scraped preferably by a service the user has to book to get their own Grafana, etc. Or how would you envision this to be used by customers? So adding a service which has to be scraped inside Cloud Foundry is a bit difficult because of network restrictions. So what I recommend here is a service which can receive a stream. For example, you can add a Graphite exporter in front of a Prometheus instance. So the application you would have to add as the sidecar should then stream the metrics to this Graphite exporter. Does this answer your question?